In 1989, Dr. McDonald shot a laser beam into a patient's eye and was hailed as the first successful LASIK surgeon. In 2011, a Massachusetts man shot a laser beam into a pilot's eye from the ground and was jailed for 3 years. So what is it that makes store-bought lasers classifiable as dangerous weapons, while making other kinds of lasers medical tools? Lasers are simply beams of light specially produced to have unique properties. Light is an electromagnetic radiation, and like all waves, electromagnetic waves carry energy.
Light from normal sources are not parallel, and so they spread out as they travel further, and the intensity decreases by the inverse square law. In a laser beam, light rays are parallel or collimated. They do not decrease in intensity noticeably with propagation, and this makes it possible to use lasers as fine cutting tools, as we shall see. Therefore, the energy of these waves can be focused onto a small spot. The effect is the same as using a magnifying glass to concentrate light.
The perceived color of light is due to its wavelength, where the wavelength is simply the distance between two peaks or troughs. Unlike natural light sources, a laser is monochromatic, meaning it emits light of only a single wavelength. This monochromatic behavior demonstrated by lasers is the reason that regular light can be dispersed or split into constituent colors, while the light from a laser cannot. Furthermore, light rays oscillate electric and magnetic fields in the same way that water waves oscillate water. In water, particles oscillate from equilibrium as they propagate, forming crests and troughs, while the particles themselves do not move. Light of different wavelengths also interact with living tissues in different ways, and thus the utilization of a single wavelength in a laser allows for specialized medical applications.
In vision formation in the eye, light has to be focused onto the retina if image is to be formed. The cornea is optically denser, and this causes light to bend towards the normal, and hence be focused on the retina. But the curvature of the cornea of the eye also plays a big role in focusing light onto the retina. In LASIK or laser eye correction surgery, small spot sizes of lasers allow them to be used as fine cutting tools. In addition, a single wavelength can be used, and this is UV because it is absorbed by cells of the cornea and does not penetrate deep enough to damage the retina.
In myopia, or nearsightedness, the cornea is curved too much and has too much focusing power. This causes light rays to focus in front of the retina, and the image can't be formed correctly. A laser can be used to cut down the cornea in the middle to flatten it. In hyperopia, or farsightedness, the cornea is too flat, and the eye has less focusing power. Light rays are converged onto a point beyond the retina. Here, a laser can be used to cut around the middle to curve it more. This increases the focusing power so light rays can converge onto the retina. So remember, do not point lasers into your eyes, unless you're medically authorized to perform LASIK.